Summer greetings all. The purpose of this screencast is to give you an overview of Chapter 1. Since you should know most of the basics in this chapter from your previous chemistry class, my goal is to hit the highlights, to make some color commentary, and to do a little bit of science and faith integration, which is often missed in texts. So I would encourage you, when you get the opportunity, to make sure you read the text, because there are some very interesting stories, such as this particular story about the Iceman, Ötzi, if I can pronounce it with that European accent. The umlaut over the O gives it kind of an sound. I'll let you read about that. It's more an example of forensic science and an application of chemistry to figure out how this individual perished. Well, let's begin by looking at chemistry and its methods. You're going to be learning a lot of these methods, or at least reviewing a lot of these methods, or going to the next level in a lot of these methods from what you learned in first-year chemistry. But first of all, chemistry is about change. Like so much of God's creation, things change, but they don't change magically, they don't change randomly. We're trying to look for underlying regularities and patterns. We're trying to understand these processes. And it's interesting that all around us we see change, but that change is never the result of something that is happening that is mindless, unguided. Nobody is in control. Certainly as Christians, we should not believe this. And when we think about change in terms of chemistry, we're thinking about how substances that we mine out of the earth or extract from the atmosphere or water can be changed by doing things to them or combining them with other substances and then seeing what happens. Sometimes it's an engagement or activity that is just done out of curiosity, and sometimes there is a particular goal or objective in mind where you're trying to achieve a certain end. One of the things we want to be able to do eventually is to become better and better at prediction. We want to be able to say, based upon what we've learned, we predict that when we combine this chemical plus that chemical, or when we do such and such to a particular substance, the following will happen. Now, of course, the only reason there can be predictions is if the universe displays regularities and patterns. And the only reason there can be regularities and patterns, ultimately, when you try to ask why this should be a characteristic of our world. And I would say that the reason for this, the best explanation, the inference to the best explanation, is that there is a creator God, and that God is a covenant-making and a covenant-keeping God. And as we see in the opening chapters of Genesis, especially right after Noah gets off the ark and later on in Jeremiah 33, God makes his covenant not just with his people, but also with his creation. And this covenant is what sustains his universe so that patterns and regularities occur, making it possible for us to even do science. It's one of the underlying philosophical principles for why science can even work in the first place. And if you take God out of the equation, so to speak, you end up with, basically, we just lucked out that our particular universe, or at least this part in which we exist, just demonstrates patterns and regularities. That will be a theme that I will come back to on a regular basis as the year progresses. Now, some of the other things we want to do is we want to understand. And I would say, again, this is something that God wants us to do. If God is a God who reveals himself, he is a God of revelation. We think about general revelation in his creation. We think about special revelation in his word. Why would God reveal himself and some of his characters and attributes if the intention was not for us to understand? And so when we do science, when we investigate his creation, we increase in understanding, not just of the creation, but the one who made the creation. Another important point has to do with this broad area of economy. Right here, talked about understanding. And of course, economy has something to do with human flourishing. Economy also has its own set of laws and principles that seem to be embedded in the operation of the universe, just like science has its set of properties and laws and principles that are embedded in it. And just as if you were to try to ignore or break the physical laws of the universe, an easy example would be gravity, there are going to be consequences. If you try to break some of the economic laws and principles of the universe, there are consequences. And then it goes without saying that if you try to break or ignore the moral laws, some by the Ten Commandments and some even further by the law to love the Lord your God with all your heart, soul, strength, and mind, and your neighbor as yourself, there are consequences. Another thing that God wants us to do is to solve problems. Sometimes these problems are just problems of we want to be able to do something better or faster or cleaner. And sometimes they're problems like diseases or destruction or other changes that threaten human beings. And this is a good example of God's very great grace that allows us to push back, to do something about the fact that we live in a broken world as a result of human sin. In other words, solving problems is part of pushing back against the fall, capital F-A-L-L, when Adam and Eve, and through them all mankind sinned. Another important point is it would be really helpful if citizens knew a little bit of science, because so many legislators are passing laws and instituting regulations that are scientific in nature, and it would be helpful to understand them in order to decide, is this the way we want to go or not? Not a whole lot of congressmen and congresswomen in the House and the Senate and other judicial bodies know an awful lot of science. They probably have a lot of aides that assist them, I hope. It's interesting that in Russia and in China, the vast majority of their principal legislators are all scientists and engineers. Now, scientists in general, and this would include chemists, do an awful lot of things that are the same in the process of going about their work, but they also do a lot of things that are different. Sometimes we talk about the scientific method, and this is important enough to write out here. And I'm going to put this in parentheses because the scientific method is not some type of formula or recipe that every scientist automatically follows and marches in step with to inexorably get results. Einstein is said to have said that if you want to know what a scientist does, if you want to know how to do science, watch what a scientist does. And every scientist does science a little bit differently. And then, in fact, some scientists even will have amazing leaps of intuition or amazing guesses or insights. And sometimes scientists have been known to have some type of dream or vision that advances the work that they're doing. So the idea of a scientific method should not be thought of as a recipe. And not all scientists do science the same way, because not all sciences are the same. Chemists do science very, very differently than most biologists would do science. And biologists often do science very, very differently than, say, an astrophysicist. And of course, if you're the kind of scientist that's looking at events that happened in the past, like archaeology or astronomy, anytime you're looking at events in the past, which are generally not repeatable, another example would be forensic science, trying to understand a crime that may have happened or a disaster. You use very different methods. In fact, you want to use an inference to the best explanation because there's no way you can repeat this activity in the laboratory. Now, some of these key things, of course, many scientists will have a hypothesis. That means that after they make lots of observations, they begin to see a pattern or regularity, and they try to state that pattern or regularity in a way that tries to identify what that relationship is. Then they might begin to design an experiment to test that particular hypothesis. Now, when we do science, when we make observations, and when we do experiments, we often take measurements. Measurements are quantitative. They involve measurements. And remember, all measurements are rounded off. Measurements are never an exact number. And so there is a certain bit of assumption every time we make measurements. We assume our measuring devices are well made and accurate, but we know that our measurements are rounded off. But I would say most of the time, despite those assumptions, we can come up with reliable measurements that we can do something with. A lot of times our work is qualitative. We're not making measurements, but we are observing things. When someday if you do a master's or a doctoral dissertation, it might be quantitative, it might be qualitative, or a mixture of both. If it is quantitative, you're going to have lots of calculations, you're going to have lots of measurements, you're going to have lots of statistical analysis. If it's qualitative, you're going to have lots of description. Qualitative has a tendency to want to look at the big picture. Quantitative has a tendency to want to get down and focus deeply on a small area or a small phenomenon. And I've had many students in the past go on in chemistry and other sciences, and I know that some of you will too as well. And I'll let you read about that. Now, one of the things that we want to say about science, and I want to make sure I didn't skip anything. I did. There we go. Talking about finding a relationship or a pattern. This enables us to make a prediction. Of course, in order to make a prediction, you are assuming that the properties and the principles that are operational as you make your do your experiment and as you make your observations are not going to change, but will be the same day after day and place after place. And if this holds up, this pattern or relationship holds up time and time and time again, then you create or state or formulate what we call a law, a scientific law. Now, there's a lot of similarities between the physical laws that we observe that describe the patterns and regularities in the universe and the moral laws that God has established in His Word, in the Bible. And we'll be talking more about that relationship later. But for now, let's remember something. Laws do not make anything happen. If I drop a pen on the floor, the law of gravity did not do that. Now, some phenomenon that is described by what we think is this law of gravity makes that happen. And that phenomenon, as we make better observations and better measurements, we sometimes modify that. But laws do not do anything. They do not create anything. They do not make anything happen. Laws are descriptions of patterns and regularities. And as C.S. Lewis has said, men became scientists because they believed in laws in nature. And they believed in laws in nature because they believed in a legislator, that is to say, a lawgiver. If there are laws, there must be a lawgiver. And I would agree with him entirely. And you're going to hear that quote in other times. But because of the regularities in the universe, as it reflects a God who is the same yesterday, today, and forever, we can therefore make predictions. And we could say, assuming that things do not change, that nothing magical or mysterious or weird or whatever happens, because we see these patterns and regularities, and we can make predictions about what's going to happen. Now, one of these patterns and regularities we see is something called the conservation of mass, right here. And if you think about it, before the time of the Reformation, we're going back to maybe the Middle Ages and earlier, it was entirely possible that if strange things happened, it was chalked up to magic. Or if strange, unexplained things happened as people lived their lives and observed stuff in the universe, or at least in their portion of the world in which they lived, that this strangeness was ascribed to the different gods, the god of the mountain, the god of the moon, the god of the sea, the god of the bear. And you had to jettison all of those mythologies if you wanted to make any progress. And during the Reformation, when all of these patterns and regularities were ascribed to a covenant-making and a covenant-keeping God, a God who is in total sovereign control over his creation, and a God who does not do things whimsically and capriciously and for no apparent reason, then you begin to see that whatever happens, there's a reason for it. Things do not pop in and out of existence for no reason whatsoever. And so this law of the conservation of mass had to become established in order for chemistry to make any progress at all. Now, a theory is going to be an idea or concept that incorporates perhaps many observations, many facts. Here we can say a fact as being something like a measurement or a pattern or regularity, many laws, and it's much more comprehensive. I would caution you never to say something like, it's just a theory, as if to dismiss it as being something that is not based upon any type of evidence whatsoever. A theory is much more robust and much more comprehensive. It still doesn't mean it's right, but it has a greater explanatory power. Now, sometimes we look for a theory that has better explanatory power than an existing theory. And so that's when, for example, Newton's laws of motion became a subset of Einstein's theories of general relativity, for example. It was a better, more robust, more comprehensive theory. Now, the goals of science, we already talked about prediction, but another goal is to control. We want to have control over these processes in the laboratory. We want to be able to control them in order to maximize the economic benefit. We want to control them in order to minimize waste and to minimize damage or danger to people or the environment. Controlling something is a direct result of the cultural mandate in Genesis chapter 1, verses 27 and 28, to subdue the earth, to have dominion. In other words, to exercise wise stewardship. This is something that God has commanded all human beings to do in whichever area God calls them. And so control is a direct consequence or flows directly out of God's mandate to have dominion, to be a wise caretaker of what God has made in order for the things that God has made to reach their fullest potential, including human beings. Now, I've already talked about understanding and explaining. But of course, neither of these would be possible if we were not rational and if the universe was not rational. If the universe was not rational because it was subject to many, many gods competing with each other, or was subject to magical forces and mysterious goings on, then no science would be possible. You could not understand, nor could you explain. And if the universe was rational, and we believe so because it's created in the image, the universe is a reflection of a rational God. If God is perfectly rational, his universe reflects that, just like any artwork reflects the artist. But human beings need to be rational as well. And why are human beings rational? Because we're made in the image of a rational God. Of course, our rationality is finite and fallen. And you're going to hear me talk about this a lot as well. Now, one of the big issues these days is in the integrity in science. More and more, we are seeing the politicalization of science. We are seeing scientists take sides on a political issue. We are seeing the media or politicians choose the scientists that either agree with them or they can get them to agree with them. And then those become the scientists that seem like they're saying what real science is or what real science says. And we really have to be careful with that because scientists are finite and fallen. Remember, there's no such thing as this idea. Science says, or follow the science. That's not true. When someone says, I follow the science, what they really mean is I am following the scientists that I have chosen to follow. Or certain scientists say such and such. But there's very little agreement across the board among all scientists on anything. And, in fact, it's healthy that scientists disagree because then, theoretically, they're supposed to enter into discussion. They're supposed to debate with each other. They're supposed to double down on their experiments to try to convince the other side so that you get closer and closer to the capital T truth of the universe. That is to say, the capital T truth of what God has instilled in his creation. Another point we need to point out is this. No scientist is perfectly objective. All scientists have bias, prejudice, previous experiences, preconceived ideas and notions. No scientist is perfectly objective. And that is good in many cases, because if you were perfectly objective, you would not be able to decide which kinds of things you don't need to take into consideration and which kinds of things you do. If you're a detective and you come onto a crime scene, or an archaeologist and you're digging out a cave, you've got to decide what's important and what's not. And that's going to be based upon your experience and based upon just maybe your gut instinct or something. No scientist is perfectly objective. You're going to hear me talk a lot more about that as well. Now, certainly in chemistry and some of the benchtop science, we always look for things to be reproducible. But not all science is reproducible, especially in terms of the historical sciences. The scientists that science that happened in the past, investigating things that happened in the past or one-time events, the historical sciences are not reproducible. This is where we get the inference to the best explanation. That's important to remember. No scientist is perfectly unbiased. That's why it's good for scientists to collaborate, and iron sharpens iron. Finally, in this introductory philosophical part, we talk about sustainability, which is a very popular term these days. And if we talk about green chemistry, and I think it's only appropriate here to go with the green. How you like that? We want to be careful here because true environmental practices and environmental concern finds its basis in Genesis chapter 1, where God gives us the responsibility to exercise stewardship, and in Genesis chapter 2, where God says to serve and protect, two Hebrew words. And that is the basis for good environmentalism, and that is going to be based upon Christian principles. But remember, there's an awful lot of environmentalism these days that is not based upon biblical principles, but is based upon a worship of the earth, so to speak, instead of a worship of the person who made the earth. Or as Romans 1 says, they worship the creation, rather than the creator. So stewardship means we want to take care of our resources. Now, certain resources do become more and more scarce as we use them, but other resources are there in abundance, and we can make them last longer with good resource stewardship. But not using resources, of course, would be, in a sense, being like saying to God, thank you for this gift that you made, but we're not going to use it. Excuse me. So we have some people that don't want to use the resources at all. God's intention is for us to use these resources to promote human flourishing, or the Hebrew term would be shalom, the peace and the well-balance of God's people in their relationships with God himself, with each other, with themselves, and with creation. Shalom. And we have a lot of people who profess environmental concern that are sadly not promoting human flourishing. That's a whole other subject, which I'll comment on periodically during the year. So some of the principles of green chemistry. Certainly we want to prevent waste. That's a biblical principle. Certainly we want to maximize the use of the materials that we are using, the resources and the raw materials. There's a whole chapter that's going to be devoted to this called stoichiometry, which is practiced all the time in chemistry. We certainly want to reduce toxicity when we do have wastes. We also want to think about the economic impact and the environmental impact of what we're doing. Some people think only about the environment, but not about the economic impact. Both begin with the letter E. The criticism often has been people are only concerned about the economics, in other words, making money, and not concerned about the environment. But to emphasize one and not the other is wrong. God expects us as people and those of us in science to be concerned about both the environment and the economic impact, because they affect people. There's a lot to be said about renewable resources, and we're finding that some of the resources that we thought were not renewable might very well be. Certainly we don't want things to persist in the universe, or I should say on Earth, for long periods of time. And we want to get smarter and smarter at things to prevent accidents. But of course, you have to remember, scientists are finite and fallen. And when you live in a broken world, where our relationship with creation itself is broken, no matter how well and carefully we do things, and I'm thinking here in terms of science, there will always be accidents, there will always be side effects, there will always be some unforeseen consequences. Those are the weeds and the tares, or the weeds and the thorns in the Garden of Eden, to use that as a metaphor from the opening chapters of Genesis. That doesn't mean we don't do science because something bad might happen. It means we have to try to minimize the possibility, be on the lookout for it, and realize that when something does happen, then we've got another branch of science where some work needs to be done. Here's another example of promoting human flourishing. A phrase used in the Bible is to live a long life, where the term long doesn't necessarily mean to an old age, but means a full life, a rich life, a consequential life, a life that has made a difference. I'm going to stop there, and that concludes an introduction with a lot of philosophy and theology to our study of chemistry.